So the test next Tuesday is going to be right around 10 problems. Some problems might have like parts A, B, and C. So also looking at around 45 points. And then just know that so far I've tested you over sections 3.1 to 3.3, 3.4 to 3.6 will be next, and then the third part will be 3.7 to 3.9. Then we will review. I'll give you plenty of problems to review. There's going to be a test over all of chapter 3. So I just want to review some things here. When we're looking at section 3.4, again, remember S of t or x of t is used to denote the position function. Then remember the relationship velocity v is always the derivative of s of t. A of t is equal to v prime of t or s double prime of t. And then we have j of t, which is the jerk. It's the derivative of acceleration, so the second derivative of velocity, and the third derivative of position. So you always want to show those relationships there. And remember, speed is the absolute value of velocity. So I just want to kind of focus on the process here when I'm asking you each question, because sometimes this can be confusing if you're not taking the time to really understand what's going on here. So if I give you a problem where an object is thrown upward, and I ask you how high does the object go? So if I'm just giving you the position function, you need to find, so let me write this out here, given s of t, so most of the time it's going to be a parabolic function. The parabola is going to open down, so we're looking for the vertex. So we need to find v of t, which is the first derivative here. So in other words, we're trying to find the vertex. So what we want to do next is solve for t, and we want to do this by setting v of t equal to 0 because we're going to have a horizontal tangent line. Once we have that, we're looking for position. So once we find t, then you want to find s of t again by substituting whatever solution you get in for that t. So let's say t is 5 seconds, then we want to find s of 5. All right, another question I could ask you, what is a velocity at a certain height? So what we'd have to do when we're given that height, we would set s of t equal to that height and then solve for t. Then we would find v of t, which again is the derivative of our position, and then substitute the t value in. So again, what's connecting this here is the t values for both of them. But in the first question, we had to find the velocity first and then set that equal to 0 to find t. Then we would find the position at that certain time value. The next question, again, we'd have to set s of t equal to that height to find the time it took to get to that height. Then we would find the derivative of the position function, which gives us velocity. Then we would evaluate the velocity function at that t value. All right, when you're asked to find the acceleration of an object, remember to write out that a of t is equal to v prime of t, derivative of velocity, which is the second derivative of the position function. If you're asked when an object is going to hit the ground, what do you think that would be? That's all about position. So that means we would set position, the position function, equal to 0. The height would be 0. Now, a lot of times we're going to get two values for this. Remember, it's on the ground right before the time starts. So we have to know when that's going to be. So that t should be equal to 0. And then as well as when the trip is over, when it hits the ground again. So the two time values that you get there, you should be able to separate them and know which one is at the beginning and then which one would be at the end. And I'm always going to repeat this. How is speed connected to one of the other functions? We don't want to use s. Remember, s is already used for the position function, so we just spell the word how. Speed is equal to the absolute value of velocity. All right, so just knowing those, I'm going to ask some questions as I just went over these, the processes here, so you might see similar questions on the test. All right, so that was just going over some things from section 3.4. So from section 3.5, knowing the 6 derivatives of the trig functions, and we go back to page 140. Those were all the problems that we were looking off of there. Chances are they're just going to mainly look like problems 1 through 10. There were some more challenging ones. I might ask for the equation of a line tangent or normal, so quite possibly 11 and 12 know those, but nothing that's going to get too crazy with the derivatives on the test. And then everything that we've been doing from pages 146 to 147 with the chain rule, know both versions of them. Make sure you look at problem number 56 off of the Inspire doc, and then also number 57, which is what I'm going to assign today. There could be parametrics on there. Chances are I will give that as a bonus. All right, so I just want to look at one more problem. And in this case, I want you to find the derivative in 2 ways. Let's go ahead and pause the video, see if you can come up with that. Okay, so hopefully you had some time to look at this. And it really just looks at the function here. Can we rewrite it a different way? And yes, we can. It is an identity, and that's where we're going to go from this. So the first way is just to leave it as it looks with y is equal to 2 sine x cosine x using the product rule. So then y prime here, we could treat this whole part here as u, and then this would be v. So u would be 2 sine x, v prime would become a negative sine x, plus v, which is cosine x, and then times u prime, which would just become 2 cosine x. So this is going to give us negative 2 sine square x, and then plus 2 cosine square x. And now maybe we could do something else with this. Let's try maybe rewriting it. I always just like to have the positive term first. And then, seeing this way, we can factor out a 2, and then we're left with cosine square x minus sine square x. Now, is cosine square x minus sine square x of importance? Is it an identity? And if you need to, look into your trig essentials packet, but yes, it is. It's actually cosine of 2x. Now, what we could have done was look at the identity first. So 2 sine x cosine x is equal to sine of 2x. And here, when we go to find y prime, we could treat it like this with the parentheses. We could use the chain rule. So this is going to become cosine of 2x times 2, which gives us 2 cosine of 2x a lot quicker. So sometimes it's helpful to rewrite first. You just never know until you try it, though. All right, so I still want you guys working on more problems. If you didn't get a chance yet to do the Inspire doc 3.6, page 147, that number 56, please do that. And in addition, go ahead and continue with these. Now, on a separate PDF that I have attached for today, I have all the problems from these pages, starting with that 19, because I had the 1 through 17. I already went over those. But starting with 19 going up to this problem 62, I have all the problems worked out. So please make sure you guys are looking over those and come ready with questions tomorrow. We are going to move on though, but I'll still take questions tomorrow. And we'll start implicit differentiation, which is section 3.7. But my main focus is if you guys do have questions over the material for the test, please let me know.